Hello, and welcome to the KC2 final review. Let's get started. Number 1, let's calculate the average rate of change. Now, the way we're going to do this is we're going to pick two perfect points, and that means they land in the perfect corners on a grid. So I have a perfect point right here, and I have a perfect point right there. We're always going to go from the left point to the right point, and it's always rise over run. That means how much we go up or down, and then how much we go to the right. In this case, it seems like we go down 1, so I'm going to put -1 for down 1, and to the right 1. So our average rate of change for number 1 is -1 over 1. Number 2, let's do the same thing. Let's find two great points. So I have this point that's right on a corner, and that point. Once again, we're going from the left to the right, so we're going to see how much we go up, down, and then how much to the right. Okay, so it seems like I'm going up 1, so I'm going to write a +1, and then 1, 2, 3, 3 spaces to the right. All right, perfect. Number 3, let's consider the table below and find its average rate of change. Now, the way we do this when we're doing it by hand is we're going to take a look at this formula. Oh, I was supposed to be in black. Let's try that again. There we go. The formula is y2 minus y1 over x2 minus x1. So let's do that. Okay, so I'm going to label everything. This is x1. This is x2. Okay, the first x, the second x. This is y1, because that's the first y. This is y2, because it's the second. All right, let's plug those numbers in. So that means we have 2 minus 7 on top over -8 minus -9 on the bottom. Okay. 2 minus 7 gives us -5. And -8 minus -9 gives us +1. So average rate of change, C, -5. Because -5 divided by 1 is -5. Let's do the same thing for number 4. Once again, we're using this wonderful formula. Let's highlight it. x1, because it's the first x, x2, because it's the second. y1, because that's the first y. y2, because that's the second y. Let's plug stuff in. -4 minus -8 over 0 minus -2. 4 minus -8 leaves us with a +4. Did I say 4? I meant to say -4 minus -8 equals +4. 0 minus -2 leaves us with a 2. And if we simplify that, 4 over 2 gives us 2. The answer is C. Number 5. A tree is currently 8 feet tall and grows 3 feet per year. Let's write an explicit formula. Okay, so currently 8 feet means that's our first term. Grows 3 feet per year, that's D, our common difference. So let's write this formula. A sub n equals 8 plus 3, and then the parentheses and -1 follows. Letter B, we're going to rewrite the explicit formula using function notation, which means we're going to do the following. Instead of a sub n, I'm writing an f of x. I'll zoom out so you can see the formula where I'm getting that from. Still equals, still an 8, still a plus, and still that 3. And instead of the letter n, I'm going to write an x and then -1 parentheses. So you should see those two formulas on screen. They're pretty much the same, except I changed it into a different notation and using a different variable. Now let's simplify this. That means what we're going to do is distribute to begin with. So I'm going to distribute the 3 to the x and to the -1. Distributing means multiplying. So the 8 and the plus stay the way they are. 3 times x is 3x. 3 times -1 is -3. I actually can simplify this just a tad further. I can combine some like terms. The two like terms that I see here are the 8 and the -3 because they are both just regular numbers. They're constants. Unfortunately, the 3x is all by its lonesome. It has nothing to combine with. But 8 minus 3 gives us a +5. How tall? Oh, I guess that's our final answer. We've simplified it as far as we could. Letter C. How tall will the tree be in 12 years? What we're going to do is we're going to take that 3x plus 5 from letter B, and we're going to plug in a 12 in there. Okay. 3 times 12 is 60, plus 5 is 65. So it will be 65 feet in 12 years. That's a giant tree. Okay, let's do that again. Number 6. A tree is currently 9 feet tall and grows 2 feet per year. 9 feet, that's our first term. 2 feet per year, that's our common difference. So our formula is AN equals 9 plus 2 parentheses n minus 1. In letter B, once again, we're going to rewrite letter A using function notation and x's instead of n's, and we're going to simplify it. The first thing that I'm going to do here is distribute that 2. My 9 stays because nothing happens to it. 2 plus 2 times x is 2x. 2 times -1 is -2. I'm going to continue by combining like terms. I can combine this 9 and the -2. There's nothing to combine the 2x with, so it's just 2x. 9 minus 2 is +7, and that's as far as we can go. How tall will the tree be in 15 years? I'm going to take the result from letter B, 2x plus 7, and I'm going to plug a 15 in there. 2 times 15 gives us 30, plus 7 gives us 37. So the tree will be 37 feet tall in 15 years. Let's continue. Number 4. F of x equals 3x plus 3. Graph f of x plus 3. Okay, so what is this telling us? F of x is this part, and I want to add 3 to it. So I'm going to rewrite f of x, and I will add 3 to it. Let's see what terms I can combine here. It looks like I have a 3 plus 3 that I can combine, so I end up with 3x plus 6. Let's graph it. The 6 is telling us our y-intercept. Our y-intercept is going to be right here at 6. The 3 is telling us our average rate of change. Remember that any whole number can be written as over 1. That means from that 6, I am going to go up 3 to the right 1 to create my second dot. Do your best to draw a straight line through it. Mine is going to look a little rough. Undo, there we go. Let's give it a shot. Do your best. When you're doing this on paper, you definitely can use your ID to create a nice straight edge. But just a reminder, the final is multiple choice. So the computer will have nice straight lines already done for you. Number 5. I have f of x. I'd like us to graph -3 times f of x. So let's first multiply. Okay. So I have -3, and I'm going to multiply it by f of x. All right, let's distribute. Negative 3 times x is I think I need to give myself some more room there. There we go. Negative 3x. And negative 3 times negative 2 is positive 6. Okay, so that positive 6 is telling us our y-intercept. That means we cross the y-axis at 6. The negative 3 in front of the x is telling us the average rate of change, negative 3 over 1. Since it's a negative, we're going to be going down 1, 2, 3, and then to the right 1. So yes, whoa, I clicked the wrong button there. Yes, we always do go to the right. So you're always going to go either up or down, and then you're going to go to the right. So there's our second point. And then, of course, draw the most straight line you can through those 2 points. Let's do that again. Number 6, we have f of x equals 3x plus 3. And then I want to graph f of x minus 3. Okay, so f of x is 3x plus 3. And I'm subtracting 3 from it. I can combine some like terms, and that's this plus 3 and this minus 3. So I am left with just a 3x because 3 minus 3 is 0. But just so we see it, I'm going to write that plus 0 because that 0 is telling us we are starting at 0. The 3 in front of the x is our average rate of change. That's 3 over 1. Since it's a positive, from the point of 0, we're going to go up 3 to the right 1 for our second point. And now we have a line. Again, yours will look much better than mine did, but yeah, that's fine. Number 7. F of x is x plus 3, and I want to graph negative 2 times f of x. Let's do it. The first thing I need to do is actually multiply negative 2 by f of x. So let's distribute that. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Let's graph it. The negative 6 over here tells us where we're starting. I picked 2 6s. Interesting. All right. Put a point right there. The negative 2 here is telling us our average rate of change. It's negative 2 over 1, which means from that point of negative 6, I'm going to go down 2 and to the right 1 for my second point. And then we can draw our, whoa, that was ugly. Let's try that again. We're going to draw our line. That's better. Okay. So graphing's a tad hard, but we always practice it every year, so we'll get better at it. Okay, oh, I love linear equations. Such a nerd. For number 8 through 11, let's solve each equation, and we're going to justify each step. All right. So, the first thing that I'm going to do here is distribute the 6. So, distributive. Okay. So, my left-hand side does not change. It's still 3x plus 9. 6 times x gives us 6x. 6 times negative 2 is negative 12. Now, we can take several different next steps. I'm just going to go in the way that feels good to me right now. What I feel like doing first is taking the x's and moving them from the left to the right. So take a moment and think, how can I take this 3x and move it to the other side, to the 6x? I'm going to do this by subtracting 3x from both sides, because I had a positive 3x, so subtraction undoes that. Okay, on the right, I'm left with just a 9. 6x's minus 3x's, 3x's, and I still have that minus 12 left over. It's just hanging out. So that's subtraction. Next, let's take that minus 12 and move it to the other side. Think about it. how do I move minus 12 to the other side? How do I undo subtraction? If you said addition, you are correct. We are going to add 12. On the left-hand side, 9 plus 12 gives us 21. And on the right, we're just left with 3x. Last, this is our most common step for finishing up equations. We're going to divide both sides by 3. The reason we're dividing is 3x is actually 3 times x. So to undo multiplication, we divide. 21 divided by 3 is 7. X equals 7. Let's continue to number 9, that's below. Okay, I didn't realize I organized it this way. That's fine. All right. Number 9, I don't see that I have to do any distributing, so that's pretty nice. I'm going to get started by moving the 2x to the left-hand side. How would I move the minus 2x to the left? If you thought to yourself addition, you're correct, because that undoes subtraction. 30x's plus 2x's is 32x's, and on the right, I'm just left with a 16. Now next to the x, I have a 32, so I'm going to divide both sides by 32. All right, so I'm left with x equals 1/2, or 0.5. All right, let's move on to number 10. Okay, there we go. Oh, I see some parentheses, which means I've got to start with distributing. So distribution. Okay. 2 times 3x is 6x's. 2 times minus 5 is minus 10. And the right-hand side stayed the way it is. Again, it doesn't matter how you start this off. I like to start it off by moving my x's to the other side. So what I'm going to do is I'm going to take the 2x from the right, and I'd like to move it to the left-hand side. What would I do to both sides? If you thought subtraction, you're right. I'm going to subtract 2x. 6x's minus 2x's is 4x's. The minus 10 just comes down from the previous step, and on the right-hand side, we're just left with a 6. Now what I'd like to do is move the 10 to the other side. Since it's a minus 10, how would you move it to the other side? If you're thinking addition, you're right. Addition undoes subtraction. So we have 4x equals 16. And now we have one last step left, and that's to divide each side by 4. So x equals 4. All right, one last one. Number 11, or at least in this bunch. Number 11 looks like we're going to have to start off by distributing because it has parentheses. So let's do some multiplying here. 7 times x is 7x. Oops, I meant to switch colors. There we go. 7x. 7 times negative 2 is negative 14, and the right-hand side stays the same. All right, as I usually like to start, let's move the x's over to the other side. I want to move the 3x to the other side. It's a positive 3x. What operation should I take to move it to the other side? If you were thinking subtraction, you're right. So on the left-hand side, 7 minus 3x's gives me 4x's. The minus 14 comes down, and the 6 is on the other side. Now our goal is always to get x by itself. So let's move that 14 to the other side. How can I move the 14? It's a minus 14. So what would I do to each side? If you said or thought, or maybe just thought, addition, you're right. Okay. On the left, I have 4x. On the right, 20. That's 6 plus 14. And I'm going to take that last step, which is dividing both sides by 4. X equals 5. Number 12. Determine whether the equation has one solution, no solutions, or infinite. So the way we're going to do it is we're going to, just take the first few steps and see what happens. Okay, on both sides of the equation, I see that, we need to distribute. So let's do it. 3 times 8x is 24x. 3 times minus 4 is minus 12. 6 times 4x is 24x. 6 times negative 1 is negative 6. And then the second negative 6 just comes along. I see some like terms on the right side. And the like terms are the negative 6's, so I'm going to combine them. Negative 6 minus 6 is negative 12. Interesting. So take a look at the x's on the left and on the right. They're the same. So you know what? We're just going to go ahead and cancel them. What are we left with? On the left side, we have a negative 12. On the right, we also have a negative 12. Does negative 12 equal negative 12? Yes, it does. So we actually have infinite solutions. You can draw the infinity symbol or you can write infinite, however you'd like to say it. But it is true, it's infinite. Okay. If we had one solution, we'd be able to continue solving it. Our x's would be different on both sides. And if we had no solution, then our leftover numbers would tell us a false statement. So let's see what happens in 13. So we should get true for infinite solutions, false for no solution, and an answer for one solution. Okay, let's begin by distributing on the left-hand side. 2 times 4x is 8x. 2 times 2 is 4. The plus x keeps, it just comes along, and it equals 9x minus 4. On the left-hand side, I see two like terms. This 8x and this x. Let's add them. 8x's plus an x is 9x's. All right. Take a look at the x's on both sides. They are the same, which means we'll either have no solution or infinite solutions, because we can just cross them off. Let's see what we're left with. We're left with a positive 4 on the left-hand side and a negative 4 on the right. Does 4 equal negative 4? No, absolutely not. This is a false statement. No solution. Number 14. Freddie saved $105. He has already spent $50. He plans to spend $15 on a movie ticket each month. Which inequality represents the number of movie tickets he can buy? Well, the total he has is 105. So the total he had, I guess, total is the word associated with addition. So if I'm thinking the total is 15 a month plus the 50 he already spent, that total should be less than 105. My answer is letter C, because he's spending $15 per ticket, and that already spent $50 has to add up to less than $105 because he doesn't have more money than that. 15. Glenn saved $120. He already spent $65. He plans to spend $12 on a movie ticket each month. Which inequality represents the number of movie tickets he can buy? Well, the total of what he can spend has to be less than 120. So once again, the word total, that's addition. Letter C. the 12 tickets per month that the $12 on a ticket that he's going to spend each month, and the 65 that he already spent must add up to less than $120 because he cannot spend more money than he has. For what? Questions 1 and 11? Well, that's a typo on my behalf. My bad. For questions 16 and 17, we're going to solve and graph this inequality. The way we solve inequalities is the same as solving equations, with one tiny difference. So when we get to that difference, I'll point it out. We're trying to get x by itself, so the first thing I'm going to do is subtract 69 from both sides. So they cancel here. 81 minus 69 is 12. My symbol comes down, equals negative x. Now recall, a negative in front of the x is actually the same as a negative 1 in front of the x. We just don't write a 1. It's invisible. So to get rid of that negative 1 that's in front of the x, we're going to follow our most common last step, which is dividing by a negative number. Now when we divide by a negative number, in inequalities, they switch directions. So check it out. We went from this symbol to that symbol. All right, let's graph it. The first thing I need to do is put an open circle on negative 12. Symbols like this or like this get open circles. Symbols like these get closed circles. So an open circle on negative 12. And x is on the greater side. It's on the open side of the inequality. So I'm going to point an arrow in that direction. Number 17. Let's once again solve for x and graph it. I'm going to begin by subtracting 59 from both sides. 77 minus 59 is 18. Bring down the symbol, negative x. And I'm going to divide both sides by negative 1. Since I'm dividing by a negative number, my symbol, my inequality symbol, flips. So we go from this symbol to that one. Oh, I lost a negative. There we go. All right. We're going to put an open circle on negative 18. And since x is on the pointy side, the lesser side of the inequality symbol, our arrow points to the left. Less is left. Right. Now, I just want to remind you, the open mouth, this area of the shark, Pac-Man, whichever you want to, alligator. I don't know what creature this is. Snake? No, snakes don't have that many teeth. It's some creature that I drew. If it's on the open mouth, this is greater. Anything on the open end is greater. Anything on the pointy end is less. Because the creature, whoever this is that I just, looks kind of like a deformed Pac-Man with sharp teeth. The creature, the inequality sign creature, always eats what's the biggest. So in number 17, the inequality creature is eating the negative 18. So x is less than it. In number 16, the creature is eating the x, so x is larger. That's the bigger side. And greater is to the right, less is left. All right, let's finish this up with number 18 and 19. The function represents the temperature range in a city over 20 hours. Ellie hates when it's hot and decides she will only go outside when the temperature is 70 degrees Fahrenheit or less. Let's graph the linear inequality on this function to represent when Ellie will go outside. 70 or less. So let's find where 70 exists. 70 exists here. Less means down, so Ellie will only go outside during this time. Number 19, the graph represents the temperature range of a city over 20 hours. Ellie hates when it's too hot and decides she will only go outside if the temperature is 75 or less. Graph the linear inequality. So this Ellie in number 19 is actually okay with it being a little warmer. All right, so 75 or less. 75 is like about right here-ish. Less would be over here, down here, this is when the temperature is less. That's how you show your work for number 18 and 19. All right, well, I hope this was helpful for you. If you have any questions for me, or if you're not my student watching this, if you have any questions for your teachers, please don't hesitate to ask. We want to help you the best way possible to make sure that you are prepared for this final. Have a wonderful rest of whatever time of day it is for you. Bye!